today's episode of Hack With Me, episode 3. Today we're going to be going over Linux basics, virtual machines, aka VMs, and running a few scripts. The scripts that we'll be running will be both in Python and Bash or Shell, but any future episodes, we will be focusing on Python scripts and Python scripts only. I just wanted to show what the comparison is with those two styles of writing scripts because they do look a little different syntax-wise. So just wanted to give a quick little intro. The last module I finished with the Try Hack Me course was the Linux module, and they had a good amount of Linux basics covered in that module. So most of that content we'll be touching base on here. I shouldn't say most of it. I would say about 75% of that content we'll be touching base on in this episode. But I also wanted to do something a little different because not everybody has access to Try Hack Me. Not everybody's going to try to get a subscription for Try Hack Me. So instead of doing the lessons and just kind of following what I did in there and kind of showing screenshots and doing screen recordings while I mess around within Try Hack Me, I decided to kind of migrate what I did within that module to just my local machine in general. In Try Hack Me, the servers that we use and test with are servers that they built themselves. And they curated those servers for the lessons. So some of the actions needed to be adjusted to work locally, but I think it's more beneficial for people that are following this series that do want to learn a little bit more about Linux, to learn how to do that without the need of a third-party, application or web application that has it curated. So we will be installing 2 virtual machines on our local using UTM, and UTM is a fully featured system emulator with a virtual machine host for iOS and macOS. For all you Windows users, sorry, this video will be more so tailored to macOS only, and the commands and scripts and everything that are, scripts should be somewhat similar. It's just the file itself. So it's not, scripts won't be different themselves, but how you run these commands, how you give the proper permissions to execute certain scripts, that will be probably a little different in macOS versus Windows. Not a lot. I'm sure Bash and Shell, those specific commands will be the same. But just note that my walkthrough will be for Mac OS specifically. And if you need any other information, if you're using Windows, I highly recommend maybe taking what you learn here and adapt it to finding out, how to do it via Windows. So let's get into a little bit of Linux lore. The name Linux is actually an umbrella term for multiple OSs that are based on the Unix system, which is just another operating system. Thanks to Linux being open source, variants of Linux come in all shapes and sizes, suited best for what the system is being used for. I guess it depends on what you're building. Linux is a lot smaller than a lot of other OSs, so it usually has a very specific use case and is customizable to a point where you can build out this operating system to have a narrow objective and a narrow scope purely for what you need it for, which makes it a lot less compute heavy for your day-to-day operations and your team that may be working on said application or said product. Now, for example, the types of Linux systems, 2 big ones are Ubuntu and Debian. So those are the 2 probably most famous and most used distributions of Linux because of how extensible they are. So, for example, you can run an Ubuntu server, such as a website or an application, or you can run Ubuntu as a full-fledged desktop OS. So like that operating system, you can use it specifically for an application, or you can do what we're doing and create an actual OS for your desktop if you were to get a mini PC or not a real PC, a bigger PC, because they're both real, but a mini PC versus a bigger PC, deciding whether or not this mini PC might do an operation for something specific. Or I guess a better example for that is if you get a Raspberry Pi and you install Linux on your Raspberry Pi in order to run commands and run scripts for whatever that Raspberry Pi is going to be hooked up to. Now, while TryHackMe's module uses Ubuntu, what we will be using is Debian, because Kali Linux is built off of Debian, and that's the distribution. I would say the owner of this particular Debian-based distribution, that's what we're going to be using, because it's Kali Linux. And then we're also going to be using ParrotOS, and ParrotOS uses Debian as well. So the two examples that we'll be working on with the VMs will be Debian, but anything that I reference related to TryHackMe is going to be Ubuntu. Now, Linux is often used to refer to the entire operating system, which is probably confusing some people when I'm saying, oh, there's ParrotOS and then there's Kali Linux. Since those are technically operating system providers, it's just how they utilize the core system, which is either Unix, and what flavor of that, which is Ubuntu or Debian or another flavor of Linux. But Linux itself is the operating system kernel that is started by the bootloader, which the bootloader itself is started by the acronym is BIOS UEFI, and that stands for, which I still don't remember exactly what it stands for, but BIOS stands for Basic Input Output System, and then UEFI stands for Unified Extensible Firmware Interface. It's a lot of words. The kernel assumes a role similar to that of a constructor in an orchestra. It ensures coordination between hardware and software, but enough of the technical jargon and the lore of Linux. If you do want to get into the history, definitely dive into it. I'm going to add a link going directly to one of the free Linux classes offered by Kali Linux themselves, and they have like a whole backstory about how about how Kali Linux came to fruition. It's a pretty cool story. Now, before we get into some basics, we're going to need to set up our virtual machines. I want that set up for everybody so that when we get to the portion where we're going to need both of them, we are already up and running. So in the article that I have written up, I have a more technical walkthrough of installing. I go through the exact process and go through the actual installation process of a new VM. On this video, the main video, I'm going to just explain what you need to do. But if you want to see it all in action, step by step, go check out the clip on the article. It's a 9-minute clip. You can up the speed to 2 times to kind of get through it a lot quicker. And then below that, I have a quick setup summary to where I just kind of roundabout tell you how to do it, or tell you where to go to get the information on how to do it. And both Kali and ParrotOS have good documentation to walk you through the steps of installing it if you need the documentation to supplement the video as well. But for us, we're going to go straight into our VM. And as you can see, I have both the Kali Linux VM here and the ParrotOS VM here. So ParrotOS is much easier to get going than Kali is, and you can still go in and edit anything with Parrot, aka you can get in and update the allotted memory. You can change the CPU cores, what have you. Now with Linux, there is a caveat in terms of getting this set up properly. Now, first thing we'll need to do is go into the Kali download pretty much homepage, and you can see various ways of downloading Kali Linux. And the installer here is what we're gonna want for this video. Now you click the installer depending on which type of Mac you have. If you have the old ones based on Intel, you would want to get this installer. But if you have any of the newer Macs with the M1 chips, you're gonna wanna get this installer. After you get that installer, we'll go back to ParrotOS, and then we can hit this plus button. Otherwise, you most likely will see, I would say, a homepage dash here to create a new one, browse, a support button, just some basic stuff to kind of guide you to creating, a new VM, just like this plus button does here. So you'll create this, and you'll want to virtualize one. Now, I've done it both with clicking pre-configured for Linux, but all of the other instructions, even on Kali Linux, they state to do other. So let's just do other. Now, my recommendation for Kali Linux for your VM for this one is to up it to 8,192. 8 gigabytes of RAM is ideal. I'm sorry, 8 gigabytes of memory is ideal for your main machine, because you're gonna want to be able to run a text editor if you prefer making code updates or creating scripts that way. I ran into a bottleneck earlier when I was doing my clips, and I only had 6 gigabytes of memory for Kali Linux. And as soon as I had 2 files up within VS Code, it was just not moving at all. It was very, very laggy. It was kind of getting locked up in certain areas to where things weren't actually operating as I clicked them. So it was pretty terrible. So I highly recommend for your main machine to bump it up to 8,192 megabytes. So you can go to next, and here's where you'll want to leave it for this portion, because we're going to be booting an iOS image. The iOS image is this image, and you guys can see all my other documents I have in here. This is the iOS image right here. So that's the one we'll be booting up. And then you find that image here, and you continue. For the storage size, you can leave it at 64 gigabytes. It just depends on how much you have available, but try to keep it at least at 40 if you need to go a little lower, but you can play around and see what works and what doesn't. You can adjust that size later too if you need to recreate this machine. Go to continue, and then before you save, you'll check up your settings and make sure everything looks right. Save it. Now, I'm not going to go through the full installation process myself, but I want to notate one thing that you need to do for Kali Linux before you install it. And again, like I said in my clip in the actual article, I go through the entire step-by-step process of installing Kali Linux. And you can see the terminals that pop up, and what I add as my username or as my host, and this, that, and the third. However, there's a known bug when it comes to Kali Linux and getting it installed for within UTM's virtual machine emulator. So what we need to do is we'll have to edit it, and we need to add a new device. And this new device will be a serial device. You will not need to change anything within the settings. These can be left alone. It's just there to help the installation when you're booting up from the ISO image. It helps fix, I don't know what the actual bug is, but it helps fix the issue of it not getting past the initial boot phase and then starting the installation process. So you can save that here. And then after you're ready, you go and press play, and it'll pop up the installation steps. And I'll even show just at least this part. This is that window that pops up when you use when you add the serial device, and then it actually works. This is what doesn't show if you don't add serial initially. Now, I'm not going to go through this process. It takes a little while, but it's pretty much a step through, and you choose yes for mostly everything. You don't really go outside of the default settings here. And then when you get to a portion to where it's asking you to partition your disk, you just say yes. The disk, the space that you assign to it is what they're partitioning. So you're not necessarily deleting anything from your actual device, like your real device that you're using these VMs on. So I'm gonna get rid of that. And that's how you get and this is that homepage that I was talking about, but that's how you get Kali Linux up. And then once that boot process and installation is done, it'll ask if you wanted to reboot. It'll reboot, and you just need to close the window and stop that server. Go back into Kali Linux, the one that you were building. Remove serial because you don't need it anymore since you already booted up and installed. And then you want to go to your virtual. You'll have a device here that is showing that it's connected to your bootable drive. You're just going to want to remove that bootable drive because we're not booting from a drive anymore. We're going to be booting from the saved and stored space that we have for our Kali Linux VM. Now, when it comes to, and then after that, you just press play and it'll boot up normally, and then I asked you to log in with your username and password. Now, with ParrotOS, it's much easier and just straightforward. Now, you can go to, let me pull that up for you guys. We'll go to ParrotOS, and they have multiple ways you can download ParrotOS. You can get the ISO package for this, but since we're using UTM, ParrotOS has individual UTM files. So you can just download the straight UTM for Apple Silicon virtual machines. Once that's downloaded, you can just drag and drop that UTM right here, and it'll generate the proper virtual machine. And one thing you need to note is that when you are asked to log in, there's instructions and documentation here as well, but they let you know that the default login is user for username and parrot for password. Once you log in with that default username, you can go ahead and change the password and username if you want. However, in our instance, since we're using ParrotOS as the target machine, I don't think we need to change that at all. You can leave it as is. The default, you won't be storing anything important in there, but that's just to let you know of how to get those two installed. Now, one thing to note is that once you have those set up, be mindful again of your memory usage. You can lower the memory of the ParrotOS machine because it comes pre-installed with 4 gigabytes of memory. This is going to be the target machine, so you might not even need 4 gigabytes. I have 4 gigabytes there. I left it as it is because I have the capacity. But if you seem to be having some issues with the rest of your machine running slow, maybe try to adjust the memory here for ParrotOS as well. So now that we have both of our machines up and running, well, not running, but both of them up and ready to go. So we'll pull up the Kali Linux machine. I have it suspended from a recent session, so it's going to boot up pretty quickly for me, but you'll usually see a nice boot up stage step through there. But let's go ahead and get logged in. Okay, so we are logged into Kali. This will fix itself in a little bit. But the first thing we want to do is just go over a few commands that are pretty basic in the land of Linux and working with the command line with Linux, mainly Unix systems, because you can see some comparisons when it comes to using some of these commands within Linux, and that you can pretty much do the same exact commands within Mac OS, because Mac OS uses their own version of Unix as well. A little remix of everything. This should be fixing itself. There it is. All right, just have to readjust the window a little bit. All right, so first things first, we want to open up our terminal. And what we'll do is we'll go ahead and just echo a few things. Echo is one of the basic and most widely used functions to just show what a quick response or a quick command and response does. So what echo will do in the terminal is just echo the sentence or string that you provided. So we can go ahead and do echo, and if it's one string you're doing, then you can do the string without quotations. But for good practice, you should just throw quotations for the string you're trying to input, because you're going to need that for multi-line, as well as it makes it cleaner when you are creating files with content and you're echoing that content within the created file. So let's just echo, hey, let's hack. And then you get the immediate response, hey, let's hack. Pretty simple. Another one is whoami. So whoami is going to list whoever the user is that is logged in and making this prompt or running this or executing this specific function. So who am I? Mortaniel. I logged in as Mortaniel. You can see the user right there. This is the host. So that's the combination of those two, if you were wondering. Another command we can use is pwd, which will print the working directory. So whatever directory we're in. So we're just in the root of Mortaniel, the user themselves. And if we want to list the contents or the directories within that location or within that specific path, we'll do ls. Now, as we can see on the screen here, we have our specific directories that we might want to navigate into. So another command, which is a basic command for all terminal navigation, is cd, which is change directory, and we want to change to the desktop directory. Now we're on desktop, and you can see that by the directory path here in our main level where the username is. Now we go through and throw a ls there, and you can see that it changes. So you see the files here. So we have the best folder, we have the cron demo.txt file, and then we have code desktop. Code desktop is this. It's just the application. So that actually proves a point for us. Light blue is anything, I think, maybe with a dot, with a proper dot extension. So while this is an application, it's reading as maybe a code file. And if it's not a text file, it goes as light blue. But if it knows it's a text file or it doesn't have one, it goes as white. That's my assumption, but enough rambling. Now there are tons of other commands available, and we'll be here pretty much all day if I decided to try to go through each and every one of them. But there are specific cheat sheets that you can go and find. There's plenty of documentation out there to look into a lot of the basic commands themselves. I will be covering a couple more commands as we come across them throughout the rest of my sections here, but I'll make sure I'll explain what they are too when I mention them. But I just wanted to stop short of any more commands other than these few basics. And again, a lot of these apply to the same thing you might do on a Mac OS. But next, we're going to talk about secure shell operations and deploy within the shell. So secure shell SSH is the common means of connecting to interacting with command line of a remote Linux machine. So in TryHackMe, we deploy two different machines. One is the Linux machine. The other one is the TryHackMe attack box. And that's where we would go over, the common shell operations, as well as how to use remotely, or how to use it to remotely log in to the other Linux machine. So what we're going to do instead, since a lot of people don't have access to TryHackMe or don't want to get access to TryHackMe, we're going to emulate both of those virtual machines within our own virtual machine space. And that's why we set up both Kali Linux and ParrotOS. So ParrotOS would be our target Linux machine, and then the Kali Linux machine would be our quote unquote attack box. Now, I tried to get Ubuntu as my second VM, but I was having compatibility issues that I did not feel like resolving while I was working on trying to get this written up and pushed out. So I'm using two Debian machines, ParrotOS and Kali Linux, instead of one Ubuntu machine. The two Debian machines will end in the same result. And we're going to be doing the same exact steps and treating the second machine exactly the same, regardless if it's Ubuntu or Debian. So there's not going to be too much of a difference there. But if you're able to do an Ubuntu machine as your second machine, by all means, go for it, experiment, and try to adapt what I go through here for your machine. And you'll find that it's mostly the same, and you might come across some roadblocks. But that's the whole idea of the software world and the development world, is you're going to always come across some roadblocks that you're going to need to resolve either in a timely manner, or you'll get a little bit of time to kind of think it through and slowly find a fun solution maybe, or just the proper solution that's needed for it. So a few operations that we're going to talk about throughout this secure shell section is the and operator, the double and operator, the greater than operator, and the double greater than operator. Now, the and operator allows you to run commands in the background of your terminal. The double and argument, the double and operator, this operator allows you to combine multiple commands together in one line. The greater than operator is a redirector, and we'll be using that in some of the examples in the next bit. The redirect of whatever that is, let's say, is we're echoing a sentence, we're echoing a string of text. You follow that string of text with the greater than operator, and then you paste the file that you want that to be replicated in or redirected to, instead of just printed out in the terminal. So the basic meaning of that is that we can take the output from a command, whether it's an echo or what have you, such as, or using the cat output, of a specific, contents of a whole file. We can take that output and then direct it to a different file to like debug something maybe, or if we need to figure out, some data that we need to grab, that's something we could use to redirect, content. The double greater than operator does the same function of the normal greater or the single greater than operator, but appends the output rather than replacing the entire file. So if you don't want to overwrite whatever you're trying to redirect, you would use the double greater than to append the content. Now let's talk about file systems really quickly. And I'm going to mention an analogy that I did come up with this time. But navigating the file system in any OS is extremely important. You're going to need to utilize the file system when you're writing in these commands or executing these scripts, because you got to know where your files live. But the file system can be summed up pretty clearly. Let's take the analogy of an RPG, tabletop or digital. In that RPG's playing field or the world, the environment, the file system is where we start. And there are many paths you can take once you leave home. Now, you get to home from leaving your roots, your family roots. And with the many paths that you can take, let's say you go from home to desktop to pictures, and then that's one path. But let's say you take a further path from that, go home, desktop, pictures of the mountain, and then actual JPEG file. That's another path you can take. Or you can go to home, downloads, straight to the file or package or image. Plenty of different paths, but you can always come back home and even further go back to your root or root file. So I haven't seen anybody make that analogy, so I'm going to call dibs. But you will want to be able to navigate your file system effortlessly, because sometimes time is not on your side when you're trying to execute or exploit or defend yourself from, an attack or some type of training situation that you might be in. So you gotta have the know-how of kind of navigating through your file system pretty quickly and correctly. All right, so let's start talking about the terminal text editors. So if you are a command line wizard, you probably want to do everything in one location, including code updates. I don't know any sane person that likes to do code updates in the terminal. Definitely when you're working on a repo bigger than a couple files. But if you want to do it, whatever. There's a way for you to do just that by accessing a code editor directly within your terminal via Nano or VIM. Nano, or GNU Nano, is a text editor for Unix-like computing systems or operating environments using a command line interface that emulates the Pico text editor. So it can be initialized with the command nano and then the file name. So let's say I wanted to add a new file to my best folder directory, and I wanted to edit the content that I added to that file. What I can do is I can create that file via the echo command and the redirect operator. And then after making that specific execution, I can then go into Nano or Vim to then edit that file, save the contents, and then check and see if that the contents were updated. So I'll go ahead and do that example now. So let's hop over to our terminal and get the file updated with some contents, and then update it again via Nano, and we'll touch on Vim after that as well.
I never got around to Vim.
So in our terminal, let's go into best folder with cd. And it'll need to be exactly how it's spelled out. Otherwise, you will get an error. Then after getting into best folder, let's echo a new sentence saying this is a new piece of content. Woo. And then we're going to want to redirect that into a file called brand new text.txt. Now we have an issue here, and it's about these quotes. Now that we have that fixed, we can list out the files in this folder. As you can see from my previous testing, there's a few text files in here. Now, what we did was brand new text.txt. So we want to see what the contents of that file is. .txt. And there we go. We are printed this is a new piece of content. Woo. I'm sure you guys love my enthusiasm. But with that being said, let's say we want to update that to a new line of text. Let's say we're not excited about the content that we just found out. So we're going to change that to boo instead. We can do that via the Nano editor. Now we would just do Nano and then type in since we're already in the folder where we want to make the change, we just type in the name of the file. But let's say we know exactly where the path is. Let's say we're back in our root and we know exactly where the path is. That's what we would have to do for opening up that specific file. You can't open up the direct file brand new text.txt from the root if that's not where it's located. So in this instance, we'll do a nano, and then we'll do the tilde. We don't need to do that, but I typically do it just for my sanity. And then desktop, and then we need our best folder, and then we need our file, which is brand new text.txt. So here we are. We're now in our file within Nano. You can see a command line down here, and it'll give you the kind of like quick shortcuts of what you need to do in order to work with this file. All we would need to do is go in here and make our changes and then save it before we leave. There's going to be a slight difference in how to make that update in Vim. You'll need to do like an insert mode and whatnot, but we'll touch on that when we get to the Vim example. So here, I'm going to change this to boo with a lot of O's. Now to save this, we're going to want to write where we're at. So we'll do a Control O. It's going to ask you if you want to write to that file. Ignore the other shortcuts on the bottom, and we'll just press enter. So now that line has been updated. We can exit with Control X. Now, if we go to print out what we have in that file again, you can, not in the proper directory. See, look at that. So let's do this. We'll just change that to cat. Now you can see the new text. This is a new piece of content. Boo. And there you have it with those quick shell commands. And that's pretty much it for using Nano to make edits to your code. One thing to take into consideration is the fact that Nano does not have any type of syntax highlighting. It doesn't have any other extensions that make coding a lot easier. So, like I say, I don't think there's going to be anybody still coding in Nano. But if for some reason you are limited to the resources that you have, and you need something extremely lightweight, Nano is the way to go. Because that is light as a feather. Light as a feather. Now let's get into some general utilities. So there are a handful of general utilities at our disposal, but I want to make sure I cover just a handful that I found extremely useful when I was just first looking into it, and the main ones that they focused on in both Try Hack Me and in this Linux Basics for Hackers book that I got. It's kind of right here. But that is downloading files, secure copy transfer, and serving files from separate servers. So to start off, we'll just talk about secure copy. Secure copy is, as it seems, it's a means of securely copying files. Working with it requires only a source and a destination. So unlike regular CP commands, this command allows you to transfer files between two computers using the SSH protocol to provide both authentication and encryption. So it goes two ways. You can copy files and directories from your current system to a remote system, and then you can copy files and directories from a remote system to your current system, provided that you know the usernames and passwords of the user for the user of the current system and the user for the remote system that you're trying to access. For example, let's say we want to copy an example file from our machine to a remote machine. Up here, I'm going to have something that reads the variable and the value, and the IP address of the remote system is going to be 192.168.130. The user for the remote system is Ubuntu. The name of the file in the local system is important.txt, and the name that we wish to store that file as on the remote system is transferred.txt. So with this information, we can craft our SCP command, remembering that it's the source and destination. And the SCP command is going to be SCP important.txt. Then it's going to be followed by the user, and the user for the remote system is Ubuntu at whatever that IP address is. So you'll put that IP in, and then you'll do a colon backslash the destination where you want that copy to be transferred. So in our case, it's going to be home Ubuntu transfer.txt. So you go back to the little image I had, you'll see that we're using both transfer.txt and important.txt. So we start off with our file, then we choose the destination for the file. Then we choose the destination for where we want that file to be copied to. Source, destination. Now let's reverse this layout and the syntax for using SCP to copy a file from a remote computer that we're not logged into. So from there to our machine. Here's where I'm going to be putting the little image. You can see that we have the same IP address as before, the same user, which is Ubuntu as before. So, but the name of the file on the remote system that we want is documents.txt. And then how we wish to store it on our system is called notes.txt. So the command would be as follows. So SCP to start the command. The destination first, where we're grabbing this information, which is Ubuntu at that IP address. See the path there. and it's the documents.txt file. And then after that is the source, where we're going to store that information, the source of that, which is in our notes.txt file. So that actually covers SCP. And in the next section, we're going to go over an example about downloading files from specific servers that we boot up on a different machine. So serving files from one machine and then downloading those served files on your current machine. I do have a specific video clip of me doing this. If you want to just check out that clip, I will still be going over this process. I'll be doing it hand in hand though. So it'll be covering the same thing I'm covering in the clip, maybe minus one example. Now we're going to want to boot up our ParrotOS, so our second VM. Now with this one, since it wasn't pre-booted, you're going to see the first initial process, and there's a countdown. Something similar to that is done for Kali Linux if it wasn't already pre-booted. And then once it's all set and loaded up, you'll get sent to the login screen. And like I mentioned earlier, I didn't change the password or the username. So it's still going to be user, and then it's still going to be Parrot, which is the default username and password for ParrotOS. I will not change it because there's not going to be anything living in this. So now with both of these up, I'm going to combine the screens. There was a little bit of weirdness going on with Kali, so I restarted it. And you can see there of its initial boot screen. So I'll relog into this one as well. So now that we have our two servers up and going, I'm going to need to create a directory within the ParrotOS to hold our new files that we're trying to serve and then trying to download. So we're going to go over a couple new commands that we haven't touched on just yet, but the make directory command, which is mkdir. And we'll name this directory new server, but we're going to throw this in the desktop just so we can see things populate in the video. I said new server, right? Okay, desktop new server. And then there you see our new server folder. We don't have any files in there just yet. So now we're going to want to get a file in here. I messed a couple things up in the process of doing that portion, so I just cleared my terminal and we'll start that over. So with the echo command that we learned earlier, we can just echo a new sentence or a new string of text within this folder. So let's say this is content served from Parrot. Sick. And then we'll add that content into our new server directory and label it. Oh, we need to make sure do that proper. And then let's label it server text dot txt. No such file or directory. So what did we do wrong? Oh, see, this is why I don't do the tilde. Every time. It's like, well, I'm already in that directory. I shouldn't need to do it again. I'm used to the Mac, but nonetheless, we have our new content within the new folder, and we see that a lot of typing and not a lot of talking, but there we go. We see that this content is served from Parrot. Sick. So now that we have our content in here that we want to serve inside of our Kali Linux machine, the first thing we need to do is understand Python and understand how Python allows us to start a simple server. So Ubuntu machines come prepackaged with Python 3, and that gives us access to very easy and lightweight HTTP server. And all we have to do is launch that server within the directory where we're trying to serve files from. So in our instance, we will launch that within the new server directory. And that command is just Python 3 with the M flag followed by http.server. 9 times out of 10, it's going to serve on port 8000. But if you're running into an error after you type http.server, follow that up with a new port to add that to add the or to launch the server from. Now let's test it out. So we are here. Let's do Python M flag http.server. So we can see that I'm now serving from this particular terminal. I want a new terminal. And then within this terminal, I'm going to look into what the IP address is, because I'm going to need the IP address to use the wget command. And I'll explain that a little bit further when I get back to the other console. So in order to get the IP, you do IP.A, or it's not .a, IP space A, and what that is IP space address is what the A stands for. And after doing that, you'll see some feedback here, and the only thing you really need to focus on is the IP address that comes after ether, and it's next to the inet. So this value here, highlighted in purple, is the target IP address that we're going to need in order to grab the files being served from this directory. Now we get back to our system, and what we'll need to do is use the wget command. And the wget command is pretty much allowing us to download files from the web via HTTP. And if I were accessing the file in a browser, I can use this to grab that specific file. So for instance, the Try Hack Me course used an assets URL. I think I have it in my notes. So yeah, they used an assets.tryhackme.com. Then it has the path to the myfile.txt file. Now that is only accessible via their machines and their platforms. I tried using that and I got a 403 forbidden error. Now, getting back to trying to get the contents from this particular file, when it comes to doing it locally, you can still access that same location. Since we have access to both of these machines, we're not going to need to worry about any permissions or things like that. So on our machine here, we can copy the files. So let's just CD into our desktop, because we want to copy the files here so you can see it populate. Now we'll use the wget command and take note of the IP address from the other machine. And what we'll need to do is do wget and do http:// the machine IP that you're targeting, the port, which is 8000 in this instance, / wherever the destination of that file lives. So in our instance, we have wget http / now we want our port, which is 192.168.64.4, and then we want our port 8000. You guys might be able to see the funkiness going on here. I'll restart this server after this again to clear that up, but yeah, that's something funky is going on there. You guys can probably see something funky going on here. I'm gonna probably restart this again and clear that up, but that'll be after this example. So after the port, we want to do another backslash, and then we want to enter the path where the information lives. So for what we want, tilde desktop, or actually, I think we don't need that. I think we just need the actual file since it's already being served from this port, and that's the port we're targeting. So we're in there. Sorry, I almost led y'all astray. So we just need the actual file, which the file was server text.txt. So let's just double check I have everything good. We have our wget command, the actual HTTP call with the port, with the IP port, and then the file. All right, so now we see that we were able to make that successful GET request. Here we were able to find the server.txt file. You can also see that the length of that file was 45 characters, and they give you what type of file that was, which was a plain text, and it gives you a timestamp of when that was saved here. If you look at our desktop, you can see that there's a new text file right there, and we can do an ls to see that it's there as well, and then a cat to server text.txt, and this is content served from Parrot. Sick. So that's cool, right? I guess that is a very simple use of the wget command. However, you can probably see now the extensibility of being able to grab content and serve content from one machine, and then retrieve it from another. Now let's move on to permissions. So on the screen, as you can see now, I pulled up my article I'm calling it an article. It's the script that I write before doing the videos. So I try to push it out as a 2-for-1. It's a part of the article. It is the article, but it is also my template for going through, discussing and talking. In my notes, if I need to reference any definitions and stuff like that. So with permissions, Linux permissions are very granular, and a user can have access to one thing while a group of people or a group of engineers can have access to another, while the owner of said company can have read, write, and execute access to everything. So if we put it in real world context, the system user that runs the web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have the want to allow their customers to upload their own files for their website without being web server system users. So compromising the security of every other customer would be the result of allowing random customers to have certain read and write accesses. So as you can see here is the definitions of the permissions. So you have read, you have write, and you have execute. So our permission is to read, which grants permission to only read and view files. Write grants you the permission to view and edit the files, while execute gives you permission to execute a file, not necessarily getting the same permissions to also view or edit it. So to move ownership from one user to another for a file that you're targeting or whatever, you would use the change owner command, which is chown. So let's say I have another user named Ringo on my Kali machine, which guess what I do? I could change the owner of a specific file to Ringo. Now I have Ringo as a new user for their own profile. I don't have them as a user within this machine. So I can do su to switch user, and then Ringo, which is the other user, and then it'll prompt me the password. And now you can see that I'm in Ringo. But one caveat here is if you don't give it a specific flag, it's gonna it's going to send you to, you're going to be still in the same directory of the original user. So you can see that I'm logged in as Ringo, but I'm in Mortaniel's directory. So we can switch back. We're back as Mortaniel, and the command for switching that user is you just do switch user and then L for actual login. And now you can see that I'm in the actual directory of Ringo. You don't need to do that to switch back to the original user. You can still just do su Mortaniel, but I threw it in there anyway. Doesn't do no harm. All right, so with that being said, in terms of how you can switch your users, I'm not transferring any of the ownership to that. I think you have to have, because let's say I tried to transfer ownership of one of these files. So chown to Ringo, and I'm transferring the ownership of the server text file. It's saying cannot access no such file or directory. Clearly there's a file there. If I go and add the tilde to be more direct, it says cannot access this particular file, no such file or directory. That's not true. It's quite literally right there. And I did not misspell anything. So I had to make sure I checked myself there. But yeah, it's I don't understand the issue yet. That is something that maybe I'll bring up later, but I didn't want to lose too much time trying to figure out a very probably simple answer behind that. But let us continue with our permissions. Now, if we want to change the permissions of a group, we would just use the command change group, which is chgrp. And then you would select the specific group that you created, and then you will select the specific package or permissions or directory or whatever that you're giving this group new access to. So this comes in handy if you are working with a team of pen testers, but the defensive or security team only needs full access to a few of the packages that you're working with. Using change group helps you assign permissions of certain packages and certain tools to an entire group. Say the defensive team that needs access to the IDS, which is the intrusion detection system, something I learned recently. Now, for further diving into permissions, we're going to be talking about how to read permissions, how to check them, how to write them, and then how these permissions are displayed in symbolic format is what they called it. But there is a symbolic format, and then there's also a numeric format that it shows up in. And you will use the numeric format when it comes to assigning new permissions or taking permissions away. Okay, so as we see here, zoom in a little bit, and we can see that permissions are stored in 3 columns. I like to look at them in threes. When I write it out, I prefer to write it out with separators within them. However, that's just with me explaining it to visually kind of see how they are. But when you're reading these commands in your terminal, they're not going to be read with a separator. So the first section of this, what I want to cover, is how you read them. There are 3 columns total. The first 3 letters, or the first column, is the owner of said environment. The next 3 applies to group, and the last 3 applies to others. Who others are, it's just whoever's not assigned to a group and whoever's not the owner of that environment. Now, each permission has a numeric value. Read gets the numeric value 4, write gets the numeric value 2, and execute gets the numeric value 1. Now, in order to determine the numeric value of what that person has permissions for, you you pretty much add those values together. So if the owner has read, write, and execute permissions, it's 4 plus 2 plus 1, which is 7. And then let's say the group only has read and execute permissions. That's 4 plus 1, 5. And then others only have read permissions, 4. So that full value, if you're changing the full value of a specific item, say a directory or a text file or a package, you would do 754 for the assignment. And then the command will most likely be change mode. So CHMOD. I'll get to that in a later example, but here you can see the example for the numeric value and how it reads out in the symbolic value and how it compares. So it shows the example. Owner can do everything, others can read and execute. 755. Owner can read write, others can only read. Nobody can execute. And then this one, the owner has full access, 700. So understanding numeric permissions is important because many Linux commands use numeric values. You can quickly identify security risks and you can control who accesses sensitive files. Now, what I was mentioning earlier, which is the change mode command, followed by the numeric permissions setting, this will assist us in changing the permissions of a specific text file or directory. So you can see here, we're using change mode, 750 system overview text. So we're changing the permissions for system overview text to give the owner full read, write, and execute access, give the group classification, write, well, if it's 4 and 1, so read and execute access, and nobody else and others get no access at all. So you can see it right there in a quick overview of what each numeric value does. So I highly recommend getting familiar with this process and familiar with reading the permissions with numeric values, because you'll be using that a lot, like I said, when you're actually working with files and changing the permissions and granting new permissions and executing things. So dive into it if you want to get a little bit more information about it. The next thing we're going to be touching on is cron jobs. Now that we're back in our Kali Linux VM, let's get into cron and the processes with cron. Throwing up the notes so I can have my references. All right, so a user may want to schedule a certain task or a certain action to take place after the system has booted. So take, for example, running commands, backing up files, launching your own favorite program, launching Spotify when you log in, or maybe launching Google Chrome when you log in. Very simple task that you can automate by using cron in the cron process. So specifically, we can interact with cron via the use of crontabs, that particular command. So crontab is one of the processes that is started during boot, which is responsible for facilitating and managing cron jobs. A cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. So cron tabs require 6 specific values. The first value is the minute value, what minute to execute at. The second value is the hour value, what hour to execute at. The third value is the date of month, what date of the month to execute at. The fourth value is the month of the year, but that's MON as the value. So that is what month of the year to execute. DOW is the day of the week to execute at. And then the actual command is the last value you need, which is the actual command that you want to execute. So let's say I want to echo a specific line of text in a specific file every minute. cron's minimal time is 1 minute for the actual values. You could try to do a little bit of trickery, I'm sure, to manipulate that to do seconds. But from what I was reading, a minute is the lowest you can go. So let's say, like I said, in that instance, I do want to make an update to a file. So let's get back to our VM, and this is the text file that I was working with during my example. So I'm gonna get rid of all of that. And we're gonna save it, and we're gonna use the same text file name. Now, this is directly on my desktop, so let's cd into desktop so we don't have to worry about being in the wrong directory initially. And what we want to do is get cron running and make an update to the cron tab file. Now what we can do to open that is use cron tab, E for edit, and then we want to press enter. Now what that will do is open up our Nano text editor, and we can just go about editing this file. All of this up here are commented out lines. You can leave it as is. It's just kind of giving you a guide on what to do in an example as well. So what I want to do though is I want to use a specific timer for this text. I'm going to try to get it copied from my other machine. There we go. Instead of 2 minutes, I want this to be 1 minute. And then here is the command that will fire off and print this in this particular text file every minute. And I'm gonna show what that looks like. I'm gonna walk away for 5 minutes and then show 5 entries. But I'm gonna save this first, which is Control right. Whoops, cancel that. That was an accident. Control O, so not Control W, and then enter to save, and then exit. Now to monitor this in the terminal, we can just run tail with an F flag, and then here we'll have our path to the file. Cron demo.txt. All right, so we see that we already got it fired off on our first minute. The second one is actually coming up soon. And there it is. So I don't have to step away for 5 minutes. But you can see how it populates in there. It's just showing the tail. So this is an active monitor, but yeah, that cron job is running that specific command, which then appends a new line of this was ran at, pulling whatever the current date and time is. All right, stepped away to feed my dog. And as you can see, the cron job has run multiple times since we have left and returned. So yeah, this is pretty much a straightforward way to use cron. Now, there are many other ways to utilize cron in a more efficient way. For example, when I worked at cars, we had a system to where we had a cron job that ran every 24 hours, different times in the day for each dealer, but at least one time a day, at least one point in the day for any particular dealer, they would have a cron job run to do a refresh of the integration plugin. And the integration plugin is pretty much just the OEM integration that came with either features or VRPs, which are vehicle result pages, other tools for admin services for that OEM. All right, and now for the last section, we are going to be running some scripts, Bash and Python in particular. Now, the title in the article states Bash scripting, but moving on For any other episodes in the future, we're going to be focusing on Python scripts. Python is a lot easier to understand, a lot easier to read, and also a lot easier to write. All in all, easier language. Bash is not too complicated. It's more so of how it's read, and you'll see the example that I'm talking about when we go through the script and how it's written in both languages. Now, in our Linux machine, we don't need Parrot anymore, but I'm going to open up Visual Studio Code, so VS Code, which is a text editor, so I can have both of my files up at the same time. You could still do something similar like that with the terminal and have two different terminals up with Nano running in both of them. Again, text editors are better. As you can see, there's syntax highlighting, so you can kind of differentiate what's what. It's just easier to read. Now, you can see here that I have one Python script and one shell script, which we're going to run in Bash. You can see the comments in the above the actual script code itself, and the first line is to let the operating system know what interpreter we're using and what we want it to use when it's executing that script. And then the other two lines are just comments. So it's just show you how you would write comments in this script to give a little bit more context to whomever might be taking a peek at the script after you're done writing it. Now, scripts can be ran in multiple languages. So most interpreter languages just need the interpreter installed, and then the scripts can be run directly in the terminal, while compiled languages needs the compile step done first, or not the compile step, but the build step done first, and then they can run and execute those specific scripts. Now, for these scripts to run, you're going to need to make them executable. They are already executable on my machine, but in order to do that, I'm going to pull up a new terminal. And what I will do is change, let's get to our proper directory. Oops. And then let's change mod. 755 is the same thing as +x. And then we're going to change the permissions of the file that we want to be able to run. So in our case, it's going to be python demo.py. So they're saying no such file or directory lives. That's right. I actually made these files in the home directory. So now I can do lsl, and you can see these files have their new permissions. Well, I wouldn't say new permissions. I've already granted them the permissions, but compared to the new file, which only has read and write permissions for both the owner and the group, and only read permissions for the other, while the shell and the Python script have read, write, and execute commands for the owner, and then read and execute commands for both the group and other. All right, so now that these are executable, let's go ahead and clear this out. And I want to touch on how these scripts are like built. So what the script is just is asking the user to do an input of a name or what have you, and that input is then stored into a variable, and then we're getting two inputs in particular, storing both of those inputs into different variables, and then in the last sentence that we print out, we're going to just be printing, one sentence that includes those two inputted values within the variable. Simple enough. Is just to show you what we can do with these scripts. Now, let's say we are doing executables in those particular variables, or let's say instead of after adding some code and storing logic and variables and functions, we're not necessarily just printing things, we're then returning something, on whatever home device or target device that we're like using. So you can pretty much look at this as like a very elementary way of trying to explain how scripts are executed. But look at the Python file here. We can see that I'm using name and fruit as different variables. Those variables are followed up by an equal operator, and that means that name is going to equal whatever follows, and whatever's following that in this instance is an input value. We're using the input function to then prompt a question, and then the input is then the return of that value. The input value is the return, and then that return is being stored in name. Same thing when it goes to fruit. And then on line 7, we're just printing out that particular sentence with those stored variables saved, and then dynamically showing in as text. And then you look at the shell command, and the shell command is worded a little differently. It reads a lot differently. No pun intended with the read command here, but the first step is you're echoing just a sentence. So that's just a printout of a string. And then the next command is a read command. The read command takes, let's say we have 3 words in the input that we want to store in 3 separate variables within our script within shell. We would then do Joe, Bob, Jill. Let's say those are our 3 names that we input. We would have to do read, name 1, name 2, name 3. With that being said, the difference that you guys will see from both of those final prints is that within the bash or shell script, I don't have to wrap the quotes in anything special, and I can just use the variables with a $ in front of them to notate that they are variables within that command or within that script. Now with Python, in order to use variables in strings, you have to wrap it in an F flag. Those are called F strings, and F strings allow you to call sentences or strings, with variables inside of those strings. Now, sometimes you might need something to return a string for a user that has updated stats. The base text is going to stay the same, but you'd want that alert or that print of anything to state whatever the new state of that variable or value is. So that's pretty much a little summary of how those scripts are working and how they're built and whatnot. So now let's move on to actually executing these. Now, for the shell script, we should be able to run it directly from the pretty much run the file directly by using the // command, and then using bash demo.py, which is the name of nope, not .py, .sh, which is the name of the file, but it needs to be in a directory, it seems. So that is something a little bit weird that I was looking into it, and I'm not seeing anything that states that it should be in a directory. So what we can do to get around that is use the bash command and then just run it from that. And then we do our input. So we have the echo, the next is a read, and whatever we input is going to store the value in read. So let's do, what's your favorite fruit? Apples. Welcome to Vice City, Rick. We have the finest apples in the country. Beautiful. But let's say we want to run the Python script. Python does work perfectly fine with this method, and we get the same list of questions. Welcome to Vice City, Morty. We have the finest peaches in the country. So those are those 2 scripts being ran. They both are built different, but they both have the same exact function. Again, this is an oversimplified way of working with scripts. Nobody's going to build scripts to do this, to print out sentences. But this shows you how to get them going, and it's up to the person that's interested in it to brainstorm what they might want to automate or what they might want to access via an exploit. or what they might want to try to defend against. A script fires off if such and such files are accessed without user permission or something, along those lines. And I'm sure there are plenty of other ideas out there that we could have used for examples, but this one was the most simple and straightforward example. So you can see everything work in tandem with these two. Like I said, I'm going to be building scripts and doing exploits in the future, adapting what I do in TryHackMe to my normal, not my normal, but my default VM that's separate from their whole tailor-made VM. I'm going to be building those scripts and testing that out, and they're going to be more complicated. They're going to be cooler and I guess more interesting than just a simple question and answer script. And that's pretty much about it. There's a lot more to cover with Linux. There's flags and switches. There's package management. There's how to navigate logs to debug and stuff like that. And then there's processes. Your machine is always running processes as soon as it's booted up. I hope you found some value in this. Leave a comment if you did. Leave a comment if you didn't. Give me your opinion on what you think I should have included in this video. But again, thanks everybody for joining. And yeah, until next time. Peace.